Hi, welcome to my video on graphing polynomial inequalities part 1. Previous video we learned how to solve polynomial inequalities. Now we're going to graph the polynomial inequalities. So if you want to pause your video and work each of these out before I do, go ahead. It says graph each, show the x and y intercepts. Notice we have y is less than or equal to negative of x plus 4 times x plus 1 times x minus 1. So what I do, I look at that I have less than equal to. So less than equal to is going to be looking at, we're looking at the negative. It says y is less than, so we're looking at the negative y's. And we're looking at less than, so less than, I always say it's below the graph after you have the graph drawn. And notice that the boundary line is equal to, so the boundary line is what I call solid. So here we go. Let's look at what we do. We look at x plus 4, so that's a minus 4. So the boundary line is the points of intercepts are included. So it's solid. And here we have negative 1, so that's solid. And here we have 1, so that's solid. And because it's negative, it's going to open down from the furthest x-intercept on the right. So, and there's all linear, so it's passing through. So what we're going to do is let x equals 0 in the equation. So y is less than negative. So if I put 0 in here, I get a 4. If I put 0 here, I get a 1. If I put 0 here, I get negative 1. So y is less than or equal to 4. So it could be 0 gives you a 4 as a y-intercept. So x is 0, y is 1, 2, 3, 4 right there. So it's intersecting through here. So we're going to come down, and it's solid because it's equal to. So it's solid. So here we go. It's, when I start up here now, remember, because it's negative, I got to start, I can't, if I start up here, it will be from a plus. So I got to start down here and come up through. So here we go. We're going up through linear, and we're going to go on up, and we're going to, when we get up so far, we're going to bend because we got to come down through here. So here we come down through, and when we get down here so far, we have to bend because we have to come up through this intercept. And notice the boundary line is solid because it's equal to, and we started from the bottom down here because it's negative, and the y-intercept is 4 right here. And now we got to find out what side we're going to shade on. So I'm going to pick the point. I'm going to pick what we call pick a test point. So the test point I'm picking, I always try to pick 0, 0. Now, if I put y is 0, less than or equal to negative, so I'm going to take x is 0 and plug in here, and I'll get a 4. Put x is 0 in here, and I get a 1. Put x is 0, and I get negative 1. So I get the same values here. 0 is less than or equal to 4. This is true. So if this is true, then this test point is included in the graph. So that means that because you have a cubic, then you have it's like you have a wall. And this goes on and on and on. So you're either on this side of the wall or on this side of the wall. So if you think about it, so because this test point 0, 0 makes this true, that means it's the point that's on this side of the wall. So your shading and shading and inequality is all these points that I'm shading. If this goes down and down and down, all these points here make this true. And I'm on this side of the wall. So take any point that I'm shading in here. So graph this. So if you want to graph the solution, so it's all the points that's in the shaded region. So if you want to solve this system, it's the same as graphing. So the solution to the system is all the shaded region, because you can't name all the points, all the shaded. Okay, notice again with the solid boundary, and because this is less than, when it's less than, I'm below. If this was greater than, I would be up here. I'll be on this side of the fence or the wall. So less than is below on one side, greater than is above on the other side. Let's look at number 2. Again, pause the video. First thing I noticed, I have a greater than, and a greater than is positive. And notice it's no equal sign, so it's the boundary is broken. The boundary is not solid. And because it's greater than, I shade above. After I get the boundary drawn, I'm shading above because it's greater than. So here we go. X squared, I have a 0, but the 0 is hollow. X plus 3 is a negative 3, and the negative 3 is a hollow. And that's x minus 2, so that's a plus 2. So that's a hollow. Now, this is positive, so I'm coming down. So this is the furthest x-intercept on the right. So I'm coming down from here, going on through, because it's a linear. And at 0 is a square, so I'm bouncing off, so I'm going down. And now I'm not concerned how far I come down. Just go down so far and bend and come back up. And at 0 is a square, so it's bouncing off, like it's tangent or a parabola. And it's coming down, and it's linear at negative 3. It's going on through, so it's going back up again. And there's that's the shape, it's a W. And the test point, I can't use 0, 0 as my test point. At my x and y intercept, when I let x equal 0, you can see because I have x is 0, y will be 0. So 0 will give me a 0. Put a 0 in here. When x is 0, 0 squared is 0, so 0 times this will give me y is 0. So we know that the x-intercept and the y-intercept are the same, and we want to use a test point. But I know, because this is greater than, that I will be shading up here on this side of the wall. Think of this side. If that was a less than, I'd be shading on this side here, like this, right here. So let's pick another point. Let's pick the point of 0, 1. X is 0, y is 1. X is 0, y is 1 in this equation. Y is 1, greater than. X is 0, so it's 0 squared. 0 plus 3, 0 minus 2. 1 is greater than. That's 0. That's a 3. That's a negative 2. 1 is greater than 0 times negative 6 is 0. 1 is, so this point is right here. This test point is right here. So 1 is greater than 0, that's true. So that means you're shading, as I knew, greater than would be on one side. So greater than is all the points that are here. Again, the solution, if you were solving it, the solution would be the shaded region. So all points that are in this region, any point that's in here will make this inequality true. Okay, let's continue. Again, we're going to graph these and see what the shading is going to be. So we have greater than equal to. Greater than equal to is positive. Equal to is a solid boundary. Solid. And greater than, it's going to be above the boundary when we got it graphed. So we have negative. Negative means, so if that was a positive, I'd be coming down from here. If that's a negative, I'm coming up. So I got x minus 1, so 1. 1 is included. It's solid because it's equal sign. And negative 3 is right here. That's a 1. Negative 3, and that's solid. So I'm coming up from to get to this intercept. So when I let x equals 0, let's see, x is 0, y is greater than or equal to negative. Put a 0 in here, and I get negative 1 cubed. Put 0 here, and I get a 3. So y is greater than or equal to, that's negative 1. That's a 3. So y is greater than or equal to 3. So that means the y-intercept is 3 right there. So here I go. At 1, I got a sideways s. So here I go. I'm going up. Oh, the boundary line is solid. I got to be careful. So it's solid. Sideways s. Goes over, through, sideways. Goes up, on, up, through. And I got to come down through the negative 3. So here we go. So the boundary line is solid, sideways s here, and down through the x-intercept of 3. And I know I got a greater than, so I bet I'm going to be shading on this side of, think of it, on this side of the fence. So all the points that I'm shading here. And again, the test point, you pick a point to be the test point. So I'm going to pick the point 0, 0. So what happens 0, 0 this time? If I'm right, 0, 0 is going to be false. So x is 0, y is 0. So y is 0, greater than, equal to, negative. I'm going to put, again, I'm going to get the same as right here. So I'm going to get 0 minus 1 cubed, 0 plus 3. 0 is greater than or equal to, that's negative 1. That's a 3. 0 is greater than or equal to 3. 0 is greater than or equal to 3? No. So this test point is not true. So I don't shade on this side of the fence. I got to shade on this side. So the solution, if you had to solve it, is all, or I should say, the solution is the shaded region. So it's all points that's in this shaded region. Remember, this goes down, down, down. So these points are out here. This goes down, down, down. So the points are out here. So any point out here, any point up here, any point going down here makes this true. Number 4, we have less than. Less than is the negative. And let's see, the boundary line is it's not equal to, so it's broken. And less than is below. So notice when we say positives, it means the x values are positive on this side and positive here, so it's related to right here, graphing on this side. And x minus 2, so that's a plus 2, but it's a hollow. The boundary line is, this point of 2 is not included. X is negative 1 right here, but is not included. X is 4, so that's 2, which is here, negative 1 here, and 4, which is right here. So it's broken. So here we go. So we have to, the furthest x-intercept on the right is 4. So because it's positive, we're coming this way. If this was negative 2, we'd be coming up this way. So we're coming down to 4, but at 4 is square. So we got to remember the boundary line is broken because there's no equal sign. So we have to do a dotted line. We're coming down and we bounce off. We got to go back up. And at 2 is linear. So I go back up. I got to come on down, bend, and go down through. And how far down do I go? Well, I'm going to let x equal 0. So y is less than 2. 0 minus 2. 0 plus 1 squared. 0 minus 4 squared. So y is less than 2. That's negative 2. That's a 1. And that's a 16. So y is less than. So that's 4 times 16 is a negative 64. So y is, when x is 0, y is negative 64. So we got to go all, if I could draw this all the way down like that and get down to far as, let's pretend that this is a negative 64 way down here. I got to come on down, and it's a broken. Keep on coming down until it goes past, and it's probably going to bend and come up, but it's going to pass through this. No, at negative 1 is going to bounce off, so it's going to come on up, up. But it's a square at negative 1, so it's going to bounce off and come back down again. So there's the graph. Notice the boundary line is broken. And that here is bouncing off. Here it's going on through. Here it's bouncing off. And the y-intercept is negative 64. And we take 0, 0 for our test point. So the test point. And I know that true, that's less than. So less than will be below. So it's not up here. It'll be below. It'll be on this side down here. So below this line is this. So this can extend down. So, and the test point is 0, 0. And if I do 0, 0, 0, 0 should be a false. So put 0, 0 in. 0 is less than. So when I put 0 in here, I'll get the negative 64. So 0, 0, and a negative 64, 0 is greater than. So that's false. So 0, 0 is not true. That means I'm shading on the other side. So the solution is the shaded region. So all points in the shaded region make this true. Okay. And the final one to do is, so what I'm doing in this question is relating the solution of this one, inequality, greater than 0, relating it to the graph of y is greater than this. So notice that x plus 1, x minus 1, x minus 3 is the same here. These are the same. So I'm relating the solution to this, which is, you only have to do a number line. So x is negative 1, which stays here. X is 1, that stays here. And x is 3, it stays here. And it's hollow. It's not equal to, so it's a hollow. And notice, because it's greater than means it's going to be, we're looking for the positives, and it's not included. Same as before, but I'm explaining the solution to this inequality and explaining it in terms of the graph. So if you pick a 4, you pick a number in between 2, pick a number in between 0, and pick a negative 2. So when I sub 4 into this one, or this is the same here, I get a positive, and a positive. So I get a positive, 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 which is a positive. When I put a 2 in, I get a positive, positive, negative, which the product is negative. When I put a 0 in, I get a positive, negative, negative. Product, positive, let me do that right, positive, negative, negative, I will get a positive. And when I put a negative 2 in, I get a negative, 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 negative. Look, I did it again. negative, negative, negative. And this product is negative. So we're looking for greater than, we're looking for the positives. So the positives is, and we're not including the 3, so it's 3 going to infinity, open, in union with, positive is here, and that's open, notice, 1 to negative 1. So these are the solutions to this inequality here, the values of x that make this true. In relation to the graph, if you notice, y equals, so we do it on the graph now. Again, the x-intercepts are negative 1, hollow, 1, hollow, 3, hollow, and we're graphing this time. Graphing is above, but notice they're all linears, 1, 1, 1, so it's moving, it's coming down, and it's broken. And we didn't find out the x, didn't find out what the x-intercept was, but let's x is equal to 0, y is greater than 0 plus 1, 0 minus 1, 0 minus 3, so y is greater than, that's a 1, that's negative 1, and that's negative 3, so y is greater than 3. So it's coming on down, going through, because it's linear at, because that's a 1, because that's a 1, because that's a 1, or same thing as here, it's going on through, coming down, bending, going up, and it's passing through. When x is 0, y is 3, going on through. When it gets up through, it's gonna, now I don't know for sure if it's going to go up like this or it's going to go up here and then come down like this, so I'm not really sure if it's going to do this. The only way to check it would be to take a half and put a half in to see if I put a half in for x and work it out, if it goes right there, then I know it's going to go up to here and come down. If I put a half in and it's here, then it might just go through here. So check that out. So it's coming down through. Again, it could go through there and bend here, or it could go. So if I put in a half into this, let's see, y, I'm putting x is a half. So I got a half plus 1. I got a half minus 1. And I got a half minus 3. And so that's 3 over 2. That's negative a half. And that's 3. So that's 2.5. That's negative 5 over 2. So work that out. And I get an 8. And I get a 15. So y is 15, 8 is almost a 2. So it looks like it's almost a 2, so about here. So it's probably going to go here and bend up here. So that's 1 7/8 positive. And if you have it equal to, so when x is a half, like this, y is 1 7/8. So I'm just saying it's going to do that. And greater than shading above. So it's not on this side, it's over here. So how are we related? Well, notice we said the answer was here, 3. So notice it's on, notice that the y value is up here, and the y value, notice the y is positive here, above, y is negative here below. But if you take the point, also, if you take the point, which is 3, 2, if you put 3, 2 into this equation, put 3, 2 into this equation, you will get 3 is, so that's 3, 2 is this point right here. So x is 3, y is 2. So there's the point right there. That's the point, 3, 2. So this 0.32 lies here. So if I take the 0.32 and plug it into this inequality, so I have that x is 2, sorry, y is 2, x is 3. Y is 2, x is 3. Y is 2, I get a 4, 2, 0. 2 is greater than 0. So the point 3 comma 2 is right here. This point is true for the inequality. So that means the shading is on this side, not on this side. But in relation to the graph, in relation to this, the y values are positive going up here, and the y values are positive right here. The y values are negative here and negative there. But in relation to the y equals, then you can see that you're on, I took a test point and it was on this side. So that goes up and up and up. So this is the solution. And that goes down, down, down. So solution is all these points. That will make it true. So I just thought I would do the inequalities to make sure that you know how to graph in relation to the polynomial functions in factored form and graphing the cubic, the quartics, the quintics, etc., etc., etc. If you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Hope you enjoyed the video. Thank you for viewing it. Bye-bye.